Alright, so let's go over some key characteristics about an isosceles and an equilateral triangle. So we talked about the main definitions and how to classify them, but let's actually go into some of the properties. So I want you to highlight your title. What is an isosceles triangle? An isosceles triangle is a triangle that has two congruent sides. Okay? So isosceles triangle means I have two congruent sides. You cannot assume a triangle is an isosceles triangle unless it has these tick marks here. If I have a tick mark here and like this, does that make it isosceles? No, because this one has one tick mark, this one has two tick marks. Okay? So the isosceles triangle, because it has those tick marks indicating that I have two congruent sides. Okay, so base angles theorem. So what the base angle theorem tells me is if a triangle is isosceles, then the base angles are congruent. So if I look at a triangle, where would its base be? Well, obviously its base is here where it sits, right? So my base angles are here and here. So I know in a isosceles triangle, I have two congruent sides and I have two congruent angles. Now, I want you to realize that angles and sides actually correspond to each other in a triangle. They're diagonal from each other. So this side over here corresponds to this angle right here. And this side over here corresponds to that angle. Since both of these angles are congruent, I can assume this is an isosceles triangle. So you can have something that looks like this or like this to show that it is an isosceles triangle. Okay? Let's talk about an equilateral triangle. What is an equilateral triangle? It is a triangle that has three congruent sides. Okay? So since down here in this picture, all three of my sides are congruent, you can also assume that all of the angles are congruent. That is what the base angle theorem for equilateral triangles is. It says if a triangle is equilateral, then all three angles are congruent, which makes sense. If we look at the corresponding sides to angles, this side corresponds with that angle. This side corresponds with that angle, and this side right here corresponds with that angle. When all of your angles are congruent, that makes it an equiangular triangle. Okay, this is another fancy word. So each angle in this triangle has to equal what in order for it to be an equilateral triangle? They all have to equal 60 degrees. Because all three of these values are the same, so there's no number that can be added by itself to equal 180 other than 60. So every triangle that has 60-degree angles means it's equilateral. Now be careful. It could have one 60-degree angle, but all three have to be congruent for you to know they equal 60 degrees. So let's look at some practice problems. It says RS is congruent to ST. RT is congruent to ST. Name two congruent angles. All right, so what two angles are congruent in this problem? Angle R is congruent to angle S. How do I know? Because this is an isosceles triangle. So its base angles are the ones that correspond to. All right. I know it's isosceles because two sides are congruent. How about letter B? It says find AB and AC in the triangle on the right. Okay, so if I look at this problem, what do I notice? I notice I have these 3 tick marks in my angles, so what does that mean? That means they're all congruent. Okay, so if all my angles are congruent, what does that tell me? Well, it tells me they're equilateral. So equilateral means all my angles are congruent and all my sides are congruent. So if this side is 11, what can you conclude about AC? Well, that's 11 too. What about AB? Well, that's 11 too. So AB equals 11 and AC equals 11. Okay? All right, let's look at C. In the diagram, find WY and the measure of WXY. So when I'm looking at this piece of information, okay, we need to figure out where we want to start. So where is something we definitely know that is true? I know these 2 angles are congruent, which makes WZY isosceles. So if this is 6, that makes this 6. Okay? Now be careful. You cannot assume WXY is equilateral because all you know is that this is 6 and this is 6. You don't know anything about this piece yet until you conclude that this triangle is isosceles, so that this is 6. So then you can conclude that WXY is equilateral. So WY equals 6. All right, so what about angle WXY? Angle WXY, that's this angle right here. Well, this is an equilateral triangle, so what are all the angles in an equilateral triangle equal? 60 degrees. Letter D. Let's look up some information on letter D. What are some things that we know? We know this triangle is equilateral. Okay. We know this triangle is isosceles. How do I know? Because of my base angles. So if this angle is 3, that means this side has to be 3. Which means if this side is 3, then these sides are 3. Okay. Find the values of x and y. So y is this whole piece right here. So what does y equal? 6. Now what about x? X is an angle. It's in my equilateral triangle. That equals 60 degrees. Notice in the directions, it said DEF was 90 degrees. Did I even use that? No. They're trying to trick you. When you're good, flip your paper over. All right, let's talk about bisecting an isosceles triangle. So let's write this down up at the top over here. Bisecting an isosceles triangle. When you bisect an isosceles triangle, 3 things happen. Okay? First thing happens, when you bisect an angle, so if you look at this problem right here, this is an example of it bisecting. So you know that your angle is bisected, which means your 2 angles are congruent. So 2 angles that are bisected are congruent. All right, what else do you know? Well, you bisect this angle here, it forms a perpendicular bisector. So bisector bisects side of triangle, which equals 90 degrees. Probably the most important piece. The last piece is that the side that is also affected by the bisector is also congruent. PS would be congruent to SR. So my third piece of information is the side bisected is congruent. Okay? Okay, so let's take a look at this problem. Now, letter E should have said blah, 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 bisected, blah, blah, blah. This is technically a bad problem. I'm telling you right now, let's assume they bisect it. So I know this is congruent to this. I know this is 90 degrees, and I know that. So I want to find X, Y, and Z. Which one do I immediately know right now? I immediately know X, which is 90 degrees. What's another one I immediately know? I immediately know Z is 50 degrees. How come? Notice it's an isosceles triangle. The big triangle is isosceles. So if this angle is 50, that angle has to be 50. Okay. Now how am I going to find Y? A couple different ways you can do it. So I know this is 50. So notice here, you have a little triangle. Okay. 90 plus 50 plus Y have to add up to equal 180. So you can say 90 plus 50 plus Y equal 180. So when you solve, you get 140. So Y would equal 40 degrees. Another way you could solve this problem is if you looked at the big triangle and you said, okay, 50 plus 50 plus this angle right here has to make 180. So 50 plus 50 is 100. So this angle right here has to be 80. Since it's bisected, these two are congruent. So Y is 40 degrees. Okay. Look at this one. Find the value of the length of each side. Well, what do you know about this triangle? It's isosceles. So that means this is congruent. No, I lied. It's equilateral because I have three congruent angles. So this side is congruent to this side, which is congruent to this side. So how am I going to set up an equation to solve for x? Well, 2x plus 11 equals 6x minus 9. Okay, so solve. 20 equals 4x, not 40. Divide by 4. So x equals 5. Okay, so if I plug in the value, you get 35 minus 9 and 21 and 21. I want everybody to try to finish the page. G, H, and then the problem at the bottom. Work with your partner. You have about 10 minutes, and then we will talk about it together. So I recommend pausing the video and solving these problems on your own, and then pressing play so we can go over it together. All right, so notice something about this problem. These are isosceles, so you know this is congruent to this. So a lot of you, I bet, started setting it up like this. Why won't this work? This will not work because you have two variables in the problem. So okay, so let's go back to the drawing board and figure out what to do next. You know this is isosceles. You know these are congruent. You know this angle is 52. Right? You know these three angles have to add up to equal 180. So these two are congruent. So if I just call these smiley face and smiley face, I have smiley face plus smiley face plus 52 has to equal 180. So if I take 152 out of 180, you're left with 128. So these two values have to add up to equal 128. So they're congruent, so you just take 128 divided by 2, you get 64. So each of my smiley faces equals 64 degrees. All right, so I'm now going to set up an equation. 6y minus 2 equals 64, and 4x plus 20 equals 64. So you have 6y equals 66. So y equals 11. over here, you subtract 20, so 64 minus 20, you get 44. So x equals 11. Look at the next one. How'd you set up this one? Well, the same way. You know these are all equilateral. If you set 2y plus 6 equal to 5x minus 3, that's obviously not going to work. But you know these equal 4. So 2y plus 6 equals 4, and 5x minus 3 equals 4. So you should get y equals negative 1, and x equals 7 over 5, which is just 1.4. This problem down on the bottom, let's figure it out. Same type of way. You know, this one's 92, so whatever these angles are, they're the same, add up to equal 180 with 92. So if I take 92 out of 180, you get 88. So these two now add up to equal 88. Divide by 2, so that means each of these are 44 degrees. Now you're going to do it the same way. Notice here, this angle makes a linear pair. So 180 minus 44 is 136 degrees. And then you're going to do the same thing because this is an isosceles triangle. So 180 minus 136 is 44. Divide by 2 is 22 and 22. From here, we are not going to go on to right triangles. We will worry about those next week. You have a couple practice problems if there is time left. I hope everybody has a great weekend.